Hi everyone. In a previous video, we have learned about the trigonometric ratios of an acute angle, and in this video, we are going to find out what would be the value of the different trigonometric ratios for a few standard angles or common angles, right? Now, if you look at the screen here, you see I have created a small little table with the 6 different trigonometric ratios, and I have listed the common angles or the standard angles, which are 0 degree, 30 degree, 45 degree, 60 degree or 90 degree. Now, for each of those angles, what would be the value of each of the trigonometric ratios? That's what we are going to calculate in this video. I'm going to show you how to calculate or how to find out the values, and then also I'll explain how to easily remember the values for each of these different ratios, right? So let's get started. First, we want to talk about the angle 45 degree. That's the easiest one. Let's do that first. Then we'll do the 30 degree and 60 degree, and after that we'll do the 0 degree and 90 degree. So let's get started with the 45 degree angle. So to determine the values of the different trigonometric ratios for 45 degree, we are going to draw a triangle, and from there we'll see how we can work it out. So let me draw a triangle first. To find the trigonometric ratios of 45 degree angle, I have drawn a right triangle here, triangle ABC, and it's an isosceles right triangle. That means we have the two sides of equal length, and the length is a unit, for example, right? So in this triangle, you can see that the two acute angles would be 45 degree each because it's an isosceles triangle. That means these two sides are equal. Let me highlight that. So this side right here, the side BC and the side AC, they are of equal length, and those are the two equal sides of the isosceles triangle, and the angle C is the right angle. So angle B would be 45 degree and angle A also would be 45 degree. Now let's try to find out the trigonometric ratios of one of the angles, right? Say maybe we can go with angle B or angle A, doesn't really matter because they both are equal. So I'll go with angle B. Let's assume that this angle B is the theta angle. So I'm going to indicate that right here. So suppose this is our theta angle, right? So again, we really don't have to use theta, but still let's just indicate that this is our theta. So I'm just kind of indicating this angle. This angle is theta, right? So now let's calculate the value of the hypotenuse here. So using the Pythagoras theorem, we can say that sum of the squares of two sides. So here we are going to write it like this, that sum of the squares of two sides. So the first side AC is a squared, well a, and square of it would be a squared, plus the square of the side BC, that is also a square, would be equal to the square of the hypotenuse, that is h square. Now from here you can see that we can say 2 times a squared is equal to h squared, and from here we can say okay, then h must be, or h squared is actually 2 times a squared, and from here we can say that h must be square root of 2 times a. Think about it. So the 2 will become square root of 2 and a squared will become a if we take root on both sides. It cannot be a negative value, it will be a positive value because we are talking about a length here, length of the side of a triangle, which is the hypotenuse, by the way. So this is one important information we are going to use in our calculation. So let me highlight that. Now let's talk about the sine of 45 degree. In this case we can assume that it's sine theta or sine 45 degree. So now I'm going to write sine 45 degree. So sine 45 degree would be opposite side divided by hypotenuse. In this case opposite side is AC, which is again of the length A, and then divided by hypotenuse, which is equal to A divided by, we have already found the value of the hypotenuse, which is square root of 2 times A. A is outside the square root, A is not inside the square root, A is outside the square root. So this is square root of 2 times A, and then you see that the A in the numerator and A in the denominator, they will cancel each other. So we are going to be left with 1 by square root of 2. So we have found the value of sine 45 degree, which comes out to be 1 divided by square root of 2. Now let's do cos 45 degree. So now we are going to do cos 45 degree, cosine of 45 degree. So in that case, what will be the value of this ratio? Well, it will be adjacent side, which is the BC side, and the length of BC side is also A. So we can say okay, that will also be A divided by the hypotenuse. That means A divided by square root of 2 times A. That will also again be 1 by square root of 2. because you see the a in the numerator and denominator, they will cancel each other, so we will be left with 1 by square root of 2, and that is the actual value of cos 45 degree. Now what about the value of tan 45 degree? Well, we can do it in two different ways. So let's find the value of tan 45 degree. So let me write it down here. Tan 45 degree will be opposite side divided by adjacent side, which is again in this case it will be a divided by a, that will be equal to 1. And also the other way, if you think about it, tan theta is actually sin theta divided by cos theta. So if you think of it like that, we can say, okay, what is the value of sin theta or sin 45 degree? Sin 45 degree divided by cos 45 degree, that will also give us tan 45 degree. This will also be same as tan 45 degree. Now sin 45 degree is 1 divided by square root of 2, and then cos 45 degree is also 1 divided by square root of 2. You see, we are dividing 1 by square root of 2 by the same quantity 1 by square root of 2. So ultimately this will also give us the value of 1. So in both the cases, you see that we found the value of tan 45 degree as 1. So far we have found all the necessary values that we need to fill in our table, right? So let's go fill in the table. I mean, from sine and cos, we can pretty much calculate the ratios of all other trigonometric ratios. If you know the value of sine theta and cos theta, you can pretty much find out the value of tan theta. You can also find out the value of all the reciprocal ratios, right? Which are cosec theta, sec theta and cot theta. So let's go fill up our table there. So now in the table, the values that we are going to fill up first would be, it would be in this column, the 45 degree column. So sine 45 degree comes out to be 1 divided by square root of 2. So let me write that down. Cos 45 degree also came out to be 1 divided by square root of 2. And tan 45 degree came out to be 1. Now let's also fill in the other rows here. For cosec theta, for cosec 45 degree, it will be the reciprocal of sine 45 degree. Sine 45 degree is 1 divided by square root of 2. So cosec 45 degree will be 1 divided by that would be square root of 2. It will be just the inverse of it. And then similarly, sec theta will be 1 divided by cos theta. That means sec 45 degree will be 1 divided by 1 by square root of 2. That will again be square root of 2. And then if you think about cot theta is actually 1 divided by tan theta, which is 1 divided by 1, and that will be 1. So we have filled in all the rows for 45 degree angle, right? Now let's try to determine the values of the trigonometric ratios for 30 degree and 60 degree. So for that, I'm going to draw another triangle, and from there we'll try to evaluate. So let's scroll down. So here I'm going to draw another triangle to find out the values of 30 degree and 60 degrees. So here I have drawn an equilateral triangle ABC, where the side lengths are equal. AB and BC and CA, they all are of equal length, and let's say the length is A unit. And then what I have done, I have also drawn a perpendicular bisector on the side BC, and that should go through the vertex A because it's an equilateral triangle, and also it will bisect the angle A. Now since it is an equilateral triangle, if you think about it, angle B, angle C and angle A, each of them would be 60 degree. And as soon as I drew the perpendicular bisector of BC, it is going to bisect the angle A also. So the little angle there, the angle BAD or CAD, each of them becomes 30 degree because the 60 degree angle has been bisected now by the perpendicular bisector, right? So let's focus on the triangle ABD. This is a right triangle, and we have one acute angle 60 degree, which is the angle B, which is angle ABC or ABD, and then we also have a 30 degree angle, which is the angle BAD. So angle ABD, so let me write it down here. We have angle ABD is equal to 60 degree, and we have angle BAD is equal to 30 degree. So for each of those angles, we are going to find out the trigonometric ratios, right? Let's first get started with the angle ABD, which is the 60 degree angle. So for that angle, what would be the value of sine theta? Well, before we go too far, let's first calculate the value of H. So H would be, using the Pythagoras theorem, if you look at angle or triangle ABD, from the ABD triangle, if you see, we can say that BD squared, I'm using the Pythagoras theorem, so BD squared plus AD squared would be equal to AB squared, which is the hypotenuse. Now let's put the values here. So BD is actually half of A, that is A by 2, square of that, plus AD is the h. So let me simply write h squared is equal to AB squared, that is a squared. The length of AB is a. So from here we can say, okay, a squared by 4 plus h squared is equal to a squared. And from here we can say, okay, then h squared would be equal to, I'm keeping the h squared on the left hand side and bringing everything else to the right hand side. So on the right hand side we already have an a squared, and then it will be minus a squared by 4. So from here you can see that this is equal to 4a squared minus a squared, that would be 3a squared divided by 4. And from here we can say, okay, then h would be, from here we can say h would be equal to, if we take the square root, it will be square root of 3 by 4 will become 2. So square root of 3 by 2 times a. So we have found the value of h, and we are going to need that. When we are going to calculate the different trigonometric ratios, we are going to need this value. So this is the value of h, which is square root of 3 by 2 times a. Now let's try to find out the values of the trigonometric ratios here. So we are going to get started with sine theta maybe. First we can do sine 60 degree. So sine 60 degree, as you can see right here. So let me start writing here. So sine 60 degree would be opposite side divided by hypotenuse. Now what is the opposite side? Well, if you look at the 60 degree angle, which is the angle ABD, its opposite side is h. So it would be h divided by hypotenuse. Hypotenuse is the AB side, which is a. So from here we can say, let's put the value of h, which is square root of 3 by 2 times a whole divided by a, right? So from here you can see that a will cancel out each other in the numerator and the denominator, and we are going to be left with the value which is square root of 3 by 2, right? Now let's find out the same ratio for cosine. So let's do the cosine 60 degree or cos 60 degree. So cos 60 degree would be, cos of 60 degree would be adjacent side divided by hypotenuse. Now in this case, what is the adjacent side? Well, the adjacent side is actually side BD, and its length is half of a by 2. So this should be half of a divided by the hypotenuse, which is a. So ultimately we get 1 by 2. So this is half. So cos 60 degree is actually 1 by 2. Now what would be tan 60 degree? Well, if we write it right here, so tan 60 degree would be sin 60 degree divided by cos 60 degree. That is one of the ways. Or the other way would be, from the triangle also we can find out that tan 60 degree would be opposite side divided by adjacent side. Now opposite side is h, adjacent side is a by 2. So opposite side would be h divided by adjacent side, which is a by 2. And in our case we know that h is actually root 3 by 2 times a, and then divided by a by 2. So from here we can say that root 3 by 2 times a, and then if we say multiplied by the a by 2 which is in the denominator, I am bringing it to the top, so it will become multiplication. So this will become 2 by a. This will become 2 by a, and then from here you see this 2 and this 2 will cancel each other, and the a's will also cancel each other. So now we are going to be left with just the root 3. So our value would be equal to just the root 3. So tan 60 degree is actually root 3. That's the value of tan 60 degree. So we have found sine 60 degree, cosine 60 degree and tan 60 degree. So let's go and fill up our table. So sine 60 degree is root 3 by 2, and cos 60 degree came out to be half, and tan 60 degree came out to be root 3. And then let's take the reciprocal ratios also, or let's put the values of reciprocal ratio. So cosec 60 degree would be reciprocal of sine 60 degree, so that would be 2 by root 3. Similarly, sec 60 degree would be the reciprocal of cos 60 degree, that would be 2, and cot 60 degree will be the reciprocal of tan 60 degree, which would be 1 by root 3. I am simply using the reciprocal values of each of those original values there. For sine, cos and tan we found the values, and then I simply took the reciprocal of each of them to fill in these 3 other rows, right? So far we have been able to fill in 2 columns. Now let's focus on the 30 degree. Let's go figure out what would be the values of these trigonometric ratios for the 30 degree angle. So let's do that. I'm going to go back to the same triangle, and now we are going to calculate the ratios for 30 degree. So we are going to use the same triangle ABD, that's a right triangle, and for the 30 degree angle we are going to find the values of the trigonometric ratios. Now if you look at the 30 degree angle, it is the angle BAD, that's the 30 degree angle, right? Now sine is the ratio of opposite side divided by hypotenuse. Now for the 30-degree angle, what is the opposite side? Well, the opposite side is actually BD. If you look at the picture, you will clearly see that the 30-degree angle is actually looking at the side BD. So sine 30 degree would be BD divided by the hypotenuse, which is the AB. So here let me write it down. So sine 30 degree would be opposite side, which is the BD. So I can write it like this also. We can say BD divided by hypotenuse, which is the AB. Now what is the length of BD? Well, BD is A by 2, and then what is the length of hypotenuse? That is A. So from here this will come out to be 1 by 2. So sine 30 degree is 1 by 2. Now let's do the cos 30 degree. So cos 30 degree will be the ratio of the adjacent side divided by hypotenuse. Now if you again look at the triangle ABD, the adjacent side of 30 degree is the AD side, and hypotenuse is AB. So then this will be AD. It will be the ratio of AD divided by AB. And what is AD? Well, AD is actually H, and divided by AB is actually A. And also let's substitute the value of H that we have from here. So H is actually root 3 by 2 times A, and then divided by, we have another A. So this is going to be root 3 by 2, because the A will cancel out each other, and we are going to be left with root 3 by 2. So cos 30 degree is root 3 by 2. Now from these two ratios we can clearly, or you can easily calculate the value of tan 30 degree, or maybe from the triangle also we can do that. Let's do that from the triangle first. So from the triangle we can say, okay, so tan 30 degree would be equal to, for 30 degree angle it would be opposite side divided by adjacent side. So opposite side is BD, that's the BD. Opposite side divided by adjacent side is AD. Now here you see BD is actually A by 2, and then AD is the H. So that will be A by 2 whole divided by square root of 3 by 2 times A. So from here we can say, okay, this becomes A by 2 times, it would be 2 by square root of 3 times A. So that will evaluate to, as you can see, the 2's will cancel out each other, A's will cancel out each other. So we are going to be now left with 1 divided by root 3. So that's the value of tan 30 degree. Now we could have calculated it based on the value of sine and cos also. So suppose, because we know tan 30 degree is also equal to sine 30 degree by cos 30 degree. So if we try this way also, let's see what value we get. So sine 30 degree divided by cos 30 degree. Now what is the value of sine 30 degree we got so far? Well, the value of sine 30 degree we got is half, which is 1 by 2, and then divided by cos 30 degree we got root 3 by 2. So this will become half times 2 by root 3, and that will become 1 by root 3, because the 2's will cancel out each other. So this will become 1 by root 3. You see, in both the cases we got the same value, 1 by root 3 for tan 30 degree. So tan 30 degree comes out to be 1 by root 3. Alright, so I think we got all the necessary values. Now we should be able to fill up our table. So let's go there and let's try to fill up. So our sine 30 degree was half, cos 30 degree was root 3 by 2, and tan 30 degree was 1 by root 3. So let's fill in the table. So sine 30 degree would be half, cos 30 degree was root 3 by 2, and tan 30 degree was 1 by root 3. And also let's fill in the rows for the reciprocal ratio. So cosec 30 degree would be inverse of sine 30 degree, that would be inverse of half, that is 2. Sec 30 degree would be the inverse of cos 30 degree, so this will become 2 by root 3. And cot 30 degree will become the inverse of tan 30 degree, so that will become root 3 by 1, that is root 3. Alright, so far we have been able to fill in the table for 30 degree, 60 degree and 45 degree. Now let's talk about 0 degree first, then we'll talk about 90 degree. So now we are going to see what would be the values of these trigonometric ratios for 0 degree angle, right? Let's try that. To calculate the trigonometric ratios of 0 degree, I have drawn 3 little triangles here just to show you the concept first. First we need to understand the concept and then we'll calculate, right? You see, in the first diagram here, we have triangle ABC, where the angle ABC is the theta angle. It's a right triangle, of course, and this is the right angle, the angle ACB or BCA, that is the right angle. In all three diagrams, please assume that angle BCA is the right angle and angle ABC is theta. So let me quickly write it down here. So we are assuming that angle ABC is equal to theta, and then angle BCA is the right angle, right? In all three diagrams, please assume that that is the case. So now you see, when I make theta smaller and smaller, you see when I'm trying to make theta approach 0 degree, trying to make it as small as possible, two things to observe here. One thing is that the opposite side of theta, which is the AC side, is actually becoming smaller. If you look at all three diagrams, I'm making theta even smaller from first diagram to the second diagram, and again from second to the third diagram I have made it even smaller, and you see the size of the AC length, meaning the length of the AC side, is actually becoming smaller and it's approaching 0. So from here we can say when theta approaches 0, there are a couple things to observe, right? When theta approaches 0, our side AC, which is the opposite side of this theta angle, it is approaching 0. So when theta approaches 0, opposite side is approaching 0. That is one thing. And the other observation here is that when theta approaches 0, you see the hypotenuse, which is the AB side, and the adjacent side of theta, which is the BC side, AB and BC, they are almost becoming equal. If you compare in the T diagram, you go from first one to second one, you see they are almost equal, and then you look at the third one, they are like almost equal. There may be almost no difference at all, right? Just slightly, maybe small little difference, but they are becoming equal. They are approaching to each other. So here we can say that when theta is approaching 0 degree, opposite side is approaching 0 and hypotenuse is approaching the adjacent side. I hope this is clear up to this point. We need to clearly understand this concept, otherwise we won't be able to calculate the trigonometric ratios of 0 degree. So for 0 degree, this is the concept that we have to understand, that when the theta angle is approaching 0 degree, the opposite side is almost becoming 0 and hypotenuse and adjacent side, they are almost becoming equal. So here we can say, okay, then when theta is equal to 0 degree, if we eventually make theta at 0 degree, then what will happen? When theta becomes 0, the opposite side becomes 0 and hypotenuse becomes adjacent side, meaning adjacent side and hypotenuse, they both become equal in length, right? So now let's calculate the trigonometric ratio values here. So from here we can say, okay, so what will be our sine 0 degree then? Sine 0 degree would be opposite side by hypotenuse. Now in this case, what is opposite side? Well, opposite side is 0. You see, opposite side becomes 0. So that would be 0 divided by hypotenuse. That will become 0. Doesn't matter what is the length of the hypotenuse, but again, it's 0 divided by something, that is 0. And similarly, what would be the cos 0 degree? Cosine of 0 degree would be equal to adjacent side by hypotenuse. Now you see the adjacent side and hypotenuse, they are equal when theta becomes 0. When theta becomes 0, the hypotenuse and the adjacent side, they both become equal. So cos 0 degree will become adjacent side by hypotenuse. So let me write it down. So it will be adjacent side. So I can say adjacent side divided by hypotenuse. You see, adjacent side and hypotenuse, they both becoming equal when theta is 0 degree, right? So that means equal divided by equal, that will give you a value of 1. And similarly, tan theta, what would be the tan theta or tan 0 degree? So let's say tan 0 degree will be equal to opposite divided by adjacent. But in this case, what is the opposite side? Opposite side is 0. So this will be opposite side 0 divided by adjacent side, whatever that may be. Opposite side divided by adjacent side. So again 0 divided by something, that becomes 0. So here we found the values, right? So sine 0 degree is 0, cos 0 degree is 1, tan 0 degree is 0. And then we can easily fill in the reciprocal values also. So let's go to the table and fill in the rows there. So here we have sine 0 degree came out to be 0, cos 0 degree came out to be 1, and tan came out to be 0. Now if you think about cosec will be reciprocal of 0, that will be undefined. So I'm going to write it like this, UND, undefined. And then sec 0 degree would be reciprocal of 1, that would be 1. And cot 0 degree would be reciprocal of 0 again, that will be undefined. Now let's use the same understanding to find the trigonometric ratios of the 90 degree angle. So let's scroll down again. To explain the concept of theta approaching 90 degree, I have drawn again three little triangles here. Triangle ABC, in all the cases I have named them similarly. Now if angle ABC is the theta angle and angle ACB is the right angle, so each of them are right triangle. So all these three triangles nothing but right triangles, right? Now if you carefully look at it, you will see that when I am making theta as close to 90 degree as possible, you see that the adjacent side length, which is the BC, it's becoming smaller, and ultimately it will become 0 when theta becomes 90 degree, right? So I'm saying that when theta approaches 90 degree, the adjacent side is approaching 0. And also, if you notice one other thing, that the hypotenuse and the opposite side, they are becoming equal. They are actually approaching each other, meaning their length going to become equal. So when eventually theta becomes 90 degree, the hypotenuse and the opposite side, they become equal and adjacent side becomes 0, right? So let me write that down. So when theta is equal to 90 degree, the adjacent side pretty much disappears, it becomes 0, and hypotenuse and opposite side, they become equal length, right? So from here, now let's try to derive the sine, cosine and tangent of all of this. So let's say sine 90 degree. So then we can say sine 90 degree will be equal to, what will be the sine 90 degree? Well, sine 90 degree is, or sine theta is actually opposite side divided by hypotenuse. But in this case, you see opposite side and hypotenuse, they are becoming equal. So I can write it as opposite side divided by hypotenuse, but they are equal. In this particular scenario, they are equal length. So this value will be equal divided by equal quantity, that would be 1. Similarly, what would be the cos 90 degree? Let's see, cos 90 degree would be adjacent divided by hypotenuse. So cos 90 degree is actually adjacent side divided by hypotenuse. Now in this case, if you look at it carefully, the adjacent side is actually now 0. When theta becomes 90 degree, the adjacent side length is 0. So that becomes 0 divided by hypotenuse, that will be eventually 0. So 0 divided by anything, that becomes 0. And from here, what would be the tan 90 degree? Let's do the tangent 90 degree, tan 90 degree. That would be equal to opposite divided by adjacent. So this should be opposite side divided by adjacent side. Now you see the adjacent side is 0 and opposite side is equal to hypotenuse. So it is actually opposite side divided by 0. That becomes undefined, right? So we now know the value of sine 90 degree, cos 90 degree and tan 90 degree. So let's go and fill up the table. So sine 90 degree is 1, cos 90 degree is 0 and tan 90 degree is undefined. And then what would be cosec 90 degree? It will be the reciprocal of sine 90 degree, which is reciprocal of sine 90 degree, that would be 1. And then sec 90 degree would be reciprocal of cos 90 degree. So reciprocal of 0 is again undefined. 1 divided by 0, that would be undefined. And then what would be cot 90 degree? Cot 90 degree would be reciprocal of tan 90 degree. Now, or if you think about it, well, reciprocal of undefined actually will be going to become 0. Why? Because cot theta is actually cos theta divided by sin theta. So if you think of it from that side, cos theta divided by sin theta, cos theta is 0, sin theta is 1. Actually cos 90 degree is 0 and sin 90 degree is 1. So cot 90 degree would be cos 90 degree divided by sin 90 degree, that would be 0 divided by 1, that is equal to 0. So cot 90 degree would be 0. So that completes our table here. And one thing I would like to mention, wherever we have the undefined, when the angle theta approaches that particular angle, for example, let's talk about tan 90 degree, right? Where tan 90 degree, we have it as undefined. When theta is approaching 90 degree, the value of tan theta approaches infinity. That undefined is actually, if we think about from the sense of limits in calculus, and when we see that the angle theta is approaching a particular value, then what would be the value of tan theta? Well, I can write it down like this. I can say, okay, when theta is approaching 90 degree, tan theta approaches infinity. So wherever we have these undefineds, you have to use the same concept that, or for example, let's say cosec 0 degree, right? So when theta approaches 0 degree, so we can write it like this. When theta approaches 0 degree, cosec theta is actually approaching infinity. It's approaching. If it is not quite 0 degree, but it's coming very close to 0 degree, then the value of cosec theta will be approaching infinity. It will approach a very, very, very large number. It's an extremely large number, right? So wherever you have this undefined, you just keep a note of this, that when the angle is approaching that particular value, then the value of the ratio will be approaching infinity. I hope everything made sense. Thank you for watching. See you in the next video.